Finally, we will be looking at the formula that gives the resistance of a given wire. We have to make a small note that it is for fixed temperature. With vary of temperature, the resistivity and the behavior changes. So, the resistance will also actually change with change in temperature, but that we are not taking into account. We are fixing the temperature. So, what are the factors we saw till now? So, the factors were, one is length of a wire, right? So, if I have a wire, if I change its length, the resistance changed. Area of cross section. So, again, if I took a wire, increase its radius, then again the resistance changed, is it not? So this is the reference wire, and I'm taking the same material but increasing the radius. So even then the resistance changed. And end of it, we have material dependent resistivity. If I take two wires of same radius and same length, okay, but different material, it changes. The resistance changes. It's not fixed. We practically saw this, right? So all of these factors play a role. Okay. Now combining all of them. So let us represent length by L, area of cross section by A, and resistivity by something called as rho, RHO. That's how you read it as. So we know that resistivity is proportional to length. We'll call this as equation 1. We know that resistance is inversely proportional to area of cross section. So from 1 and 2, we have R is equal proportional to length by area. Now, when I remove this proportionality symbol and make it an equal to symbol, see, proportionality talks about only how it's related to the things which it depends on. If you change the length and area, things will change, right? But for a given material, only if you change the length and area, things will change. If not, it won't change, right? So we're looking at a given fixed material. But when we remove this proportionality constant symbol, we have to put equals to sign, and we have to put something called as proportionality constant into length by area. Okay, so length by area will continue to be there. And when you remove proportionality symbol, you have to write proportionality constant. And this constant turns out to be material dependent. Okay, and that is represented with the help of resistivity. So therefore, we have the formula of resistance to be R is equal to rho L by A. And this is your final formula, right? So again, resistance will vary with change in length. That is, it will increase with increase in length and decrease with increase in area. And of course, for a given material, the things will change, is it not? Right? So this is the formula for a fixed temperature. Okay. So in the next section, we'll be looking at unit of resistance and resistivity and how do we define it.